Alright, I want to look at one of the substitution method integrals that might come up here. So what we're going to do is we're going to look at this integral here. Let me get it. This was sent via a request coming through. So we're going to have the integral. We're going to look at 5 e to the x dx over 1 plus e to the 2x. And on the interval, and this is going to be a weird interval here, negative root 3 over 3, negative natural log root 3 over 3 to 0. Make sure I have everything in there right. Yeah. And so a couple things to note. So firstly, let me see if I can center this better here. Oops, there we go. So firstly, this is a definite integral, so we're going to get a number out of this. Secondly, it doesn't have a form that we have within our known antiderivatives. So, but what I'm going to note here is this looks really close to, we have e to the x and e to the 2x. This is like a u and a u squared. So I'm going to play with the idea. I'm going to use as a substitution u equals e to the x. And thus du will be e to the x dx. And this lets us rewrite this in a very neat way. So first, I want to replace the bottom as 1 plus u squared. And then at the top, well, this could be 5u, but we actually have here du. So we'll put 5 du. And now I need to change my my bounds on my integration. So if I put 0 into e to the x, I'm going to get an upper bound of 1, right? So u of 0 equals e to the 0, which equals 1. And then if I do u of negative ln root 3 over 3, that becomes e to the negative ln root 3 over 3. And, well, what can we say here? We have a natural log of a negative, so this is e to the ln of, what does the negative do? That flips it, 3 over root 3, which means that we get an answer of 3 over root 3. Oops, 3 over root 3. And so this sets up the integral we can do here. I'll pull the 5 out. And pulling the 5 out, let's see here, pulling the 5 out leaves me with 1 over 1 plus u squared du, which this is arctangent. Viewed from 3 over root 3 to 1 and 5 times whatever the answer is. And so arctangent 1 minus arctan 3 over root 3 all times 5. And so that's pi over 4 minus, let's see, 3 over root 3. Looking at my arctangent sequence, let's see, 3 over root 3 is 3 over root 3. What is that? That's negative. So it's going to be positive pi over three. And so 3 pi over 12 minus 4 pi over 12, or negative 5 pi over 12. And so this is us getting a substitution in. It's neat to note that when looking at substitutions like this, that we look for places where our substitutions can come back. When I first looked at this, I looked at making e to the 2x, and so I would get 2e to the 2x, but I realized I couldn't substitute it back in top. And a really big thing to note here is how e to the x is its own derivative shows up in integration here. Right? It shows up as its own derivative by having an extra part here. And that's an important concept for us to look at.